Example 1.7. This example aims to find the skin temperature of a human by evaluating the amount of conduction, convection, and radiation going through that particular skin. This problem is steady, one-dimensional with constant properties, and the energy generated is equal to 0. The information that is given is the internal temperature, the surrounding temperature, the air temperature, and the values of the convection coefficients for air and for water. Also, the cross-sectional area, the thickness, and the emissivity are given. Let's start the analysis with a balance of energy. We have the energy going in minus the energy leaving plus the energy that is generated is equal to the change of the energy that is stored. Since this case is steady, this value is equal to 0, and there is no energy generated, so this is equal to 0. This equation then simplifies to the energy going in has to be equal to the energy going out. For our case, the energy going in is equal to the conduction heat flux, and the energy leaving is a sum between the convection plus the radiation. Let's just start with the conduction part. Conduction is governed by Fourier's law. So the conduction part is given to the gradient of temperature. Since this is a linear case, one-dimensional, we could rewrite this as the change of temperature divided by the length. And if we organize the temperatures, it gives us, now if we want to remove the negative value, we could simply rewrite it as Ti minus of the surface. The convection component is governed by the cooling law of Newton and is given to be the convection coefficient, the surface temperature, and the surrounding temperature. For this particular case, we are going to assume that the fluid temperature is equal to the surrounding temperature. For the radiation, we're going to use the Stefan-Boltzmann law. We're going to assume that emissivity and absorptivity are exactly the same. Therefore, the flux due to radiation becomes emissivity, Boltzmann constant, temperature of the surface to the 4th power, and the surrounding temperature to the 4th power. Once again, the conduction is the energy going in, the convection and the radiation are the energies going out. We're going to put them now together into this equation. After putting all the components together, this is the energy going in due to conduction, and this is the sum of the energies going out by convection and by radiation. The point of this problem is to find Ts, which is the skin temperature. Notice that in the first component is on the 1st degree, the second component is on this 1st degree too, and in the last component is in the 4th degree. To solve this problem, there are 2 different ways that you could do it. One, trial and error. You select a value of Ts, depending on your knowledge, you plug it in, and you solve for, you do a couple of iterations, or you enter into MATLAB, which is what your assignment is going to be. So please enter this equation into MATLAB, and using the tools of MATLAB, solve for the value of Ts.